Okay, so welcome to section 8.2, complex numbers in trigonometric form. So complex numbers in trigonometric form. Okay, so let's recall. Actually, I really don't like the way that N looks. It's driving me crazy. Or that T. Numbers in... that looks a bit better. Okay, so let's recall that complex numbers are of the form. So complex numbers are of the form Z is equal to A plus BI, where A is equal to the real part and B is equal to the imaginary part. So that is two parts. Okay, so let's note. So in order to plot a complex number, so note, in order to plot a complex number, we need two number lines. Need two number lines corresponding to the real and imaginary parts, respectively. Imaginary parts, respectively. Okay, so how do we graph complex numbers? So graphing complex numbers Okay. So in order to plot a complex number, in order to plot I not write the word in order to plot Z equals to A plus BI, an element of the complex numbers. So we use a plane. So we use a plane with horizontal axis equals to real axis and vertical axis equals to imaginary axis. Okay. So let's note the above is termed the complex plane, and the vertical axis axis is annotated by IY. Annotated by IY. Instead of just the y-axis, it is now the IY axis. Okay, so by convention, this is just what we do. Convention, complex numbers are plotted as vectors or directed line segments. Directed line segments from the origin. Okay, so how shall I say this? For example, let me just do an example. If I had z is equal to a plus bi in the plane, in the complex plane. So now remember, my vertical axis is not just the y-axis. So I have the x and iy. So this is the complex plane. Complex plane. Because we have iy as our vertical. So if I have z, what color did I use there? So say this is A and this is B on the IY axis, then Z is not just the point here, it's the directed line segment here in the plane. So this is Z equals to A plus BI. So let's note. Z equals to A plus BI has magnitude or length. Norm of Z equals to the square root of A squared plus B squared. Okay. Now if this were to have made an angle theta, which it does, with the positive x-axis, do you agree that tangent of theta induces a direction, which is B over A, is the direction of Z? Now we're going to rename these, but for the time being, it's similar to vectors. So for example, so let's plot the following complex numbers. Complex numbers in the same plane. Same plane. So number one, let's say I have z1 is equals to 3 plus 4i. Number two, let's say I have z sub 2 is equals to 2 minus I. Number three, let's say I have z sub 3 is equals to negative 4 plus 4i. And number four, let's say that z sub 4 is equals to 2 minus, or 2, negative 2 minus 5i. How about that? Okay. So now I've got my xiy coordinate plane. This is the complex plane. 2, 3, 4. I need to make this a bit longer. Let's see. Okay, so let's see. Here we are. So this is the x and iy, because this is the complex plane. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so let's color code. So Z1 is 3 plus 4i. So that means I go to the right 3 and up 4, and that is the terminus of that quote, quote vector. So 3 plus 4i. Let me write that equal sign a bit better. Okay, so now let's look at z sub 2, which is to the right 2 down 1. So this is z sub 2. Z sub 2 equals 2. 2 minus 1i. Now let's look at z sub 3, which is to the left 4 and up 4. So here's z sub 3 equals to negative 4 plus 4i. And then z sub 4, left 2 down 5. Oop, what happened? So we have that z sub 4 is negative 2 minus 5i. Okay, so this is how we plot vectors in the complex plane. Okay, so let's recall. That x is r cosine theta, and y is r sine of theta. So, what is the magnitude of r? Well, it's going to be the square root of x squared plus y squared, right? Using the main Pythagorean identity. Okay, so let's say we had z is equal to x plus I times y. Okay, well, what is x? X is r cosine theta. Actually, you know what? I need more room. Let me move that down one line. So x is going to be r cosine theta plus I times y is going to be r sine of theta. So there's an r common to both. So z, I can factor out the r, and what's left is cosine theta plus I times sine of theta. Okay, so this, of course, would be the trigonometric form of a complex number. So definition. Okay, so let's let z be equal to a, I'll do a plus bi. So a plus bi is a complex number. So then the trigonometric form. So then the trigonometric form, no, metric form of z is given by, so we're defining the trigonometric form, and it's going to be z is equal to radius r times the quantity cosine of theta plus I times sine of theta, where r is the magnitude of z, the radius, which of course in this case is the square root of a squared plus b squared, termed modulus. So for complex numbers, the terminology is a bit different. than vectors. So the radius, or quote magnitude, is now termed modulus. And theta, which of course is tangent inverse, or inverse tangent of b over a, or y over x, termed what used to be called direction, is now termed the argument for complex numbers. Modulus and argument. Okay, so I will see you in the second video for 8.2.